Over the past decade, anti-inflammatory diet trends and clean eating movements have surged in popularity, with promises of reduced chronic inflammation, improved energy, and lower risk of metabolic and cardiovascular disease. These diets often emphasize whole, unprocessed foods, minimize added sugars, avoid refined grains, and sometimes eliminate entire food groups such as dairy, gluten, or animal products. While the benefits of anti-inflammatory foods, rich in fiber, antioxidants, polyphenol, and healthy fats, are well established, emerging evidence suggests that overly restrictive approaches can unintentionally compromise metabolic health by creating micronutrient gaps, affecting energy regulation, and reducing overall nutrient diversity. Understanding these risks allows individuals to maintain the positive effects of anti-inflammatory eating while safeguarding essential metabolic needs, offering a more nuanced and sustainable approach to dietary wellness. A key concern in highly restrictive anti-inflammatory diets is the risk of micronutrient deficiencies. Eliminating entire food groups can reduce intake of nutrients critical for energy metabolism, bone health, and immune function. For example, removing dairy may lower calcium, vitamin D, and iodine intake, potentially impacting bone mineralization and thyroid function. Excluding animal protein sources without careful planning can limit vitamin B12, heme iron, and zinc, nutrients that play central roles in red blood cell formation, DNA synthesis, and enzymatic reactions involved in metabolism. Even seemingly healthy substitutions, such as plant-based alternatives, may not fully compensate for bioavailability differences. The positive takeaway is that with thoughtful inclusion of fortified foods, diverse plant proteins, nuts, seeds, and select supplements, these gaps can be bridged, allowing anti-inflammatory diets to retain their health-promoting qualities while meeting essential nutrient requirements. Restrictive eating patterns can also influence metabolic regulation in subtle ways. Many clean eating diets prioritize low-glycemic, minimally processed foods, which provide stable energy and support glucose control. However, extreme elimination of carbohydrate sources such as whole grains, starchy vegetables, or legumes may inadvertently reduce total energy availability and fiber diversity, which are critical for optimal gut microbiome function, short-chain fatty acid production, and hormonal regulation of satiety and metabolism. A compromised gut microbiota can influence nutrient absorption, inflammation signaling, and insulin sensitivity, potentially offsetting some of the anti-inflammatory benefits the diet seeks to provide. The encouraging aspect is that by reintroducing a variety of carbohydrate sources, preferably nutrient-dense and minimally processed, individuals can maintain energy balance, support microbiome diversity, and preserve metabolic flexibility while still adhering to anti-inflammatory principles. Healthy fats, a cornerstone of anti-inflammatory eating, are generally beneficial for metabolic health, brain function, and cardiovascular protection. Yet, overly restrictive patterns that limit certain fats, such as saturated or omega-3 rich sources, may inadvertently compromise nutrient intake. For example, excluding fatty fish can reduce long-chain omega-3s, which are essential for cardiovascular and cognitive health, while overly restricting nuts and seeds can limit magnesium, vitamin E, and certain B vitamins important for enzymatic energy metabolism. Fortunately, alternative sources such as algae-based omega-3 supplements, diverse nuts, seeds, and plant oils can effectively fill these gaps, allowing anti-inflammatory diets to deliver heart-protective and metabolic benefits without nutrient compromise. This illustrates a key positive insight. The flexibility of anti-inflammatory eating allows for tailored modifications that enhance nutrient adequacy without undermining core principles. Protein intake is another area where restrictive anti-inflammatory diets can unintentionally create metabolic challenges. Plant-based emphasis and avoidance of animal products may reduce intake of high-quality, complete proteins, which are essential for muscle maintenance, enzymatic activity, and metabolic signaling. Lower protein consumption can impact nitrogen balance, reduce lean mass, and impair postprandial thermogenesis, which in turn may influence energy expenditure and insulin sensitivity. The encouraging perspective is that careful combination of complementary plant proteins, legumes with grains, nuts with seeds, can provide a full spectrum of amino acids. Additionally, targeted supplementation or inclusion of select minimally processed animal products, such as eggs or yogurt, can further optimize protein intake while remaining largely aligned with anti-inflammatory goals. Another positive consideration is that anti-inflammatory diets emphasize foods rich in polyphenol, antioxidants, and fiber, which support immune function, reduce oxidative stress, and enhance cardiovascular and metabolic health. These properties can partially compensate for minor nutrient gaps if energy intake and macronutrient balance are maintained. For instance, fiber from a diverse array of fruits, vegetables, and legumes supports glycemic control and gut microbiome diversity, while phytonutrients modulate inflammation signaling, even when certain micronutrients are suboptimal. This demonstrates that the foundational benefits of anti-inflammatory diets remain intact, provided that attention is paid to overall dietary variety and nutrient density. Finally, meal planning, mindful supplementation, and diet personalization are critical for optimizing anti-inflammatory eating without compromising metabolic needs. Regular monitoring of micronutrient intake, especially for calcium, vitamin D, iodine, B12, iron, zinc, and long-chain omega-3s, combined with flexible inclusion of fortified foods or supplements, allows individuals to maintain the protective benefits of anti-inflammatory eating while preventing deficiencies. Incremental reintroduction of nutrient-rich foods that may have been excluded for restrictive reasons, such as certain whole grains, legumes, or sustainably sourced fish, can further enhance metabolic resilience, support hormonal regulation, and improve long-term adherence. This approach emphasizes a positive, sustainable perspective. Anti-inflammatory eating does not have to be rigid or extreme. When implemented thoughtfully, it supports both inflammation control and comprehensive metabolic health. In conclusion, overly restrictive, clean eating, and anti-inflammatory diet patterns can unintentionally create gaps in essential micronutrients, energy availability, and protein intake, which may impact metabolic regulation, bone health, and gut function. However, these challenges are largely preventable through careful meal planning, dietary variety, strategic supplementation, and inclusion of nutrient-dense foods that align with anti-inflammatory principles. The positive insight is that anti-inflammatory diets offer significant health-promoting benefits, reducing oxidative stress, supporting cardiovascular health, and improving metabolic function, while remaining flexible enough to meet essential nutrient needs. By balancing anti-inflammatory focus with micronutrient adequacy, individuals can enjoy the synergistic effects of these diets on overall wellness, energy metabolism, and long-term health outcomes.